USP and Professor Rafael from Federal University of Rio Grande do Norte. So I'd like to invite you for the round table. So maybe we can start the kickoff with questions from the audience. And speakers may use both microphones. So anybody want to make a first kick? Okay, Gustavo.
This was a great session. There's a lot of connection between all the talks, right? So this brings to the fact that quantum networks is probably one of the, I'll tell my impression from the other meetings, okay? Quantum communications, I think it's definitely the strongest point in our quantum community in Brazil. Given the maturity, not only on the theory side, but also on the experiments going in the country and using different platforms, right? So do you all see a possibility of what kind of convergence we can have? Because I see a bit of a divide, I must say, right? We have one initiative here, one there, one here. I mean, São Paulo State is lagging behind, right? Rafael just started, and he's pushing this São Paulo State. We've seen work from São Carlos, but my take is, of course, Rio and the Northeast are advancing faster than São Paulo. And even, okay, Rio is an example, but I'll take Rio out of the factor because of the history of quantum science and technology there. So how do we, as a community, push this together, right? I like Rafael's talks in the point that he's been collaborating with Italy mostly, right, on these recent experiments. And I'd like to consider that, and I'll ask in the end, Rafael, is why this is not happening with Brazilian researchers. Okay, why not you could propose one of these tests in the Rio network or in the Recife network or even in the São Paulo network that eventually will be set up here. So what is missing, right? So in a way, it's a bit of disconnection, right? We have an outstanding theorist publishing high-impact papers with an Italian group. We have a lot of work on the local networks. It seems that we are a bit disconnected, despite this being the most advanced topic among sensing, quantum computing, and quantum communications. What's your take on that? Maybe it's a bit too long, but just...
I can talk about that from two different perspectives. From the perspective as a researcher, a scientist, and from the perspective of a member in the scientific committee of a funding agency, which is FAPER. So my impression, did you notice how many authors there were in the papers Rafael showed, and from how many different institutions they were? So it seems that our community is still have not developed the ability and, how can I say, the habit to make big works in collaboration. So I think that we grew up in a context where we were motivated to be a lot independent and to do our own jobs in our own labs. So there is an upper bound where you can reach in this manner. If we want to do like big projects, as we are now talking about, like national network for quantum communication and so on, we must think beyond that. We must act coherently. And this is something that our community is not used to do. I think that it's a skill that we still have to develop. And I think that all this initiative that we are doing is a start. So we are starting in this business, in this sense. And it's not very easy to convince people to move from their like safe ground of doing their own work in their labs to go in some adventure in a biggest, how can I say, entrepreneurship. But I think that we need to do that because we, otherwise the society will like very soon ask us, what are you doing after all? Only papers. So we have to show something big, and I think that it would make us much prouder and more visible to the society. That's my opinion.
No, just like to remember that, I mean, actually we do talk, né? The various groups. I mean, we submitted a INCT project, everybody together, so it's 100 researchers. And the idea was to do exactly that, I mean, to work together. So I think there is a goodwill to work together, but we do need mechanisms to do that. And I think this National Institute for Science Technology would be a good project to do, I mean, to fund movement among the groups and to fund some common ideas. No? But it was not approved for now, but I think at least the seed was there. Everybody talked, and then I think we discussed a lot this initiative. But I can free Rafael from explaining why he didn't do the experiment here in Brazil, but he couldn't do that. So I think the groups in Brazil, I mean, we are reaching, I think, the point to have some minimal network, a quantum network that could do something like that. I hope in Recife we'll be able to do soon, but we still cannot. That's the point.
I think one of the things that I noticed is that there has been, and I think it was also clear from all the talks today, that we are very much at the beginning. Everyone here is representing a project which has a different take on it, right? And they don't have, they have some things in common, but not all that much. And they are still very basic, right? Because you're trying to do proofs of concept, basically. And everybody is starting at about the same time, right? So in one way you could ask, why were not a bigger project already from the beginning created? And that is difficult. I think the culture in Brazil of you being tenured in some way and being free to do whatever you want to, you only do it with whoever you want to as well. So it goes by personal affinity, right? So for you to break that and to be able to think more globally, right, you have to have some particular large calls for research, for proposals that will serve as catalysts. Because the truth is everybody here, and I dare to find somebody that doesn't have more things to do than it's able to, right? Everybody has, you go and develop new projects and activities to the limit of what you can do, right? So for you to go out of what you already have planned and you go and doing that, you need to have a catalyst. You need to find something interesting. And there is 2 ways you can do that. You go to a conference, you go to a meeting, and you find out there is somebody interested in exactly what you have, you are interested. Then a nice partnership will come. But that usually doesn't happen because we are not that many, right? And everyone is doing their own little thing, or not so little, sometimes big thing, and it's a lot of work. But what I see is that I think we are, in the area of quantum communication, we are creating this community, right? And then we are meeting each one in one of the meetings, either in CIMATEC, here at the ICTP, I'm sure there's going to be another one in Unicamp, another one in Rio, and then we kind of meet, and we are getting to know each other and their work, right? And with that, I'm feeling more hopeful that we'll be able to do longer things. But you don't build that from overnight. It takes time, and it takes persistence, right? So one thing that Brazil is not good at sustainability, right? You have lots of money, you have something becomes fashionable, everybody goes, does, builds, and then it dries. And then you are struggling to survive and maintaining the little that you have conquered. And then you go through a dry period for a few years, and then all of a sudden something else appears and everybody jumps there. So as long as and that's the reality, right? So everybody's trying to survive in a way or another to do that. So the National Center would be interesting. It can serve as a catalyst for putting those things together, but it can't be, what I've seen in the meetings that I've been, it's that whenever we asked people to talk and what they are interested in, everybody is talking about what's best for them and not what's best collective. I think I've seen only one meeting, one person going and say what Brazil needs is something that they were not doing. That they were not directly involved. So we are a very individualistic society, and everybody is very busy and trying to survive. So that doesn't play so well for collaborations. But I think we have a start. I mean, we are already collaborating with the people from Rio, with Rafael Chaves, with Rafael Barros, we start talking. We haven't talked too much yet, right, with Felinto. And I think we're starting to do that. And I think in Cimatec and in Queen, we have a differential because we have this interest and the opportunity to bring things that are from research to the marketplace, right? Or to do a startup or a company to do this development. And that's, I think, something that the community is very interested. Everybody would like to see that their life's work would be turned into something, as long as they don't have to be that person that do that, because it's not the interest, the personal interest, nor the skills that most of the researchers have. You have to have people with other skills. So in that sense, I think I hope that we'll be able to work with more people because we want to develop products. We want to bring things, and that's the only way we can grow in a sustainable way. Because whatever we do, if you grow the research, it's going to continue this cycle. Grow, 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 dry. Grow, 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 and reduce. Because if you don't create a sustainable system where people can be hired, the students can be hired, and the companies, it takes time. But I'm hopeful because I'm starting to see some real interest in changing that, and I'm not trying to be partial, but I really like the work that Embrapi does for stimulating that in many other centers, in other areas, and I think that will help this thing. Again, we don't know how sustainable it's going to be, right? It's okay now, they have money for that now, but who knows what's going to happen in 2 years with a different government, with everything else. So nobody knows. But that's my take.
Well, I'm relatively new to the community in general, so I left as a PhD student and came back 4 years after to start something. So I'm not as familiar to the collaboration scheme and how it goes. So my take on it is that everybody that I talk to is very excited to collaborate. So like the mood overall is really nice, but in particular in the area of quantum communications, I think the way to go would be to try not to reinvent the wheel, because we are trying to do something that people have done 20 years ago. Not everything, but 90% of it. Like we need to send light from one point to the other point. We need to measure it. We need to make it like resource efficient because we know that money is going to end at some point. So I think the best we could do is to accelerate each other. So nobody loses the time, because like time is of the essence when money is going to run out. So I think now what could improve or like what could make it more efficient, because we are already collaborating and talking a lot, would be to try to assess the technical challenges, which will not bring us papers or any, like any personal gain or any gain for the group in particular, and to try to assess what can we do to help each other. Like, I don't know, I don't work much with fibers, so I don't know how to correct for the polarization, but I work with structural light, or I don't know, I think we have complementary skills. And one thing that could be very good is to try to accelerate each other in this sense. Everybody gains. I think it's a win-win situation, yeah.
Gustavo, Brazil, 30 times in terms of surface, the France surface. So it's really big country. I think this is one of obstacle that in some way decelerate this effort in collaboration. But Brazil appeared in the survey of Cureca in 2021. So as someone said, we are at the beginning. I remember GSN in 2017 make an agreement with Telecom in order to offer support for quantum communication, especially for the election inside the Swiss country. So we need to speed up, but I can see there is group working hard with result. I think the bottleneck always is in the moment to in the transfer to manufacturing. I mean, as GSN did in the past, it is interesting to get in contact with the enterprise offering telecommunication application and ask what they really need and how the university can help supporting the transfer of this new technology in the old one, I mean the classical telecommunication.
Yeah, so I would like to just take from something that Zella said. Some years ago, we did a study on the ICT. We took data to understand how was the network. And two things that I remember. First is that there were a lot of local collaborations, but not many regional collaborations. And the other thing that reflects what Zella said is that most of the papers were with very few authors. It was very unlikely to find a paper that involved a lot of people. And I think this reflects something that it's very wrong in the Brazilian system. There is no incentive to do big science. In the end of the day, you just do the salami science and you get CNPq productividade, and that's what matters in the end. So, I mean, we are thinking very small. So I think that the problem is much bigger. If this doesn't change from up, I don't see how this would, I mean, at least I have 1,200 reais more in the end of the month, and that's it. I'm not going to change. I mean, I'm not saying that I think like this, but this is, I think, reflected among many of us. So the change should come from up. And the other thing I see that we spend a lot of money on big money, but in small pots. And this is just not going to work. It doesn't make sense to give 1,500 or, I mean, to give 200,000 reais for a project that it's going to last 3 or 4 years. In CNPq now, doing this ad hoc, most of the budget I mean, if you sum up everything, it's like, I don't know, 300 million, but most of the projects are like, okay, I want to buy 3 laptops, I want to buy, I want to have a per diem and buy some flights to enjoy Europe. I mean, really, why? This makes no sense. Like to have this money, like this small money pulverized everywhere. So I think we need big projects. And then I was talking with Breno, and I remember when I came back to Brazil, I came to UFABC. He was still, well, he was in the beginning of his lab. And then I was very happy. He was telling me now that he's getting the first papers published. It was, I don't know, 8 years. I don't know, but probably he doesn't have the CNPq, whatever. So we should change that, right? Like the guy is doing something from scratch and he's not being recognized. So this is one point. And the other is that I think what is missing, we need the center. Brazil is just too big. Like, okay, I took a flight from Natal 2 in the morning yesterday, but I'm still young, but I don't know for how long I can continue to do that. I mean, I'm going back tomorrow. I have 2 small kids at home. I mean, we need a center. We need a place where people, like a hub where people can go and pass time and collaborate. This is happening like everywhere. I've been to this new center in Abu Dhabi a few times. In 3 years, what they've done there is just, I mean, of course, they have a lot of petrol dollars, and this helps a lot, but it's also the vision. They have like a big center where they congregate, where everyone is there, like talking all the time. Like, yeah, so I think this would be very important to stop like spreading money everywhere and like concentrate money in a single place. Like, okay, this is what we want to do and that's what we are going to do. And why I don't collaborate with, well, I do, mostly in theory. In experiment, so when I started as a PhD student, 2005, I think, in Rio, you know, back then, the theoreticians from Europe were coming to Rio to do the experiments there. I remember Nature, Science, tons of PRLs. Because we had the money, the gap was still not that big, and they could do like experiments at the edge of the knowledge. But like during my PhD, I saw this changing. Like in 2008, I think, we had an idea to do a 4-qubit experiment that like Pan would do blind, and it took like, so we started having this idea in 2018, and the paper was published in 2014. It was 6 years to do the 4-qubit experiment. It was done, but it took 6 years. So, I mean, maybe I should just take the time, but like, it's much easier. Like, I talk with Fabio. He needs to buy something that costs 10,000 euros. Next week it's there. So it's just easier. I mean, we should not do the easy thing. I should change my mindset, but yeah, it takes time. But yeah, I think having a center, stop spreading money everywhere. It's a beginning, and I would be like in 5 years, I would like to repeat this study that we did and see how the community changed. Like if we started to have more connections between regions, between universities, if the profile of the number of authors in the papers changed, and these sort of things. I think this would show like maturity of the community.
Okay, another questions?
Yeah, thanks. I want to pick up on what Rafael just said, because it's actually what I was going to start saying, which is precisely this, that sometimes in Brazil we feel like we are working on the surface of Mars, because if you need to buy a new crystal or just a wave plate or whatever, you might have to wait for a year, and then, yeah, it's gone. And so I'd like to know, especially since we have 3 representatives from 3, let's say, big projects in Brazil now, how are you being affected by this supply chain issue, also by HR issues, especially in lab technicians? And also, I mean, in the end, the fact that it's big funding, but when we compare to the projects that are being funded in Europe, it's let's say not so big. And since we don't have the technology base in Brazil, we have to buy everything abroad, so it gets more expensive.
I think the main difficulty we are having is on the importation of equipment. Certainly the problem with CNPq with the quota last year has impacted us a lot and had many repercussions because as trying to get around it, we end up involving legal, and as a result, we just have more bureaucracy. And so that is a problem. And I think everybody probably goes through that because the import process it's really slow. Regarding people, the HR, I mean, we knew that there was not a good supply of people to work on it. So we know that we have to form, particularly because we are addressing some of the engineering issues, and the engineers don't know quantum. And who knows quantum is physics, but the physicists not always have the practical and the engineering mind to do. And then we need to connect those. So the option that we did is, that, well, if that is known, we're going to form them, we're going to teach them. It just take a little longer to do that. But I'm getting happy about that we have. One thing that I think is pathetic in Brazil is the value of the fellowships, right? How can you pay a fellowship of 2,000 reais for a master's student? Is way too little, right? So that's a limiting. So we have the advantage that we don't need to be limited by that. We can pay more, and that helps a lot, including getting good people, right? So that's good. But I think the problem is, in order, what I say it's a long ways, because the problem is that for you to have a vibrant community, so you can keep the best people, you can pay them well, you have to develop industry. And we don't have that industry developed. So we have a little bit of a chicken and egg thing because we don't have the industry, so we don't have the engineers, we don't have the engineers because we don't have the industry, and how you do that. And that is going to take some time. There is no way around, right? That's the thing, but that's it.
So, I mean, some of my experience is the same as Valeria. I mean, the importation process, and particularly when suddenly you have a second semester of a year without being able to import anything, then you can easily lose 1 year of a 3-year project. and that's really a little bit very strange, to say the least. In the end, you end up the project, and the funding agents cannot say anything, basically, because I mean, you lose because of something else that's not related with your research or with your effort. No? But with respect to forming people, I think we are seeing, I'm feeling now a very different moment, I think, in Brazil, because I think this area of quantum technology is attracting a lot of attention. And I mean, we are really being able to bring people with other background to the field. And I think actually I didn't mention that, but the first product of the network in Recife is to form people. We are being able really, since we have different nodes, we have people being formed in each of the sites, related with each of the sites, and is really being a multiplicative factor for training people. And this is working quite well, particularly, I mean, with the combination of physicists and engineers, because, I mean, at least our approach in Recife is to put everybody to work together, and then we use the abilities that are complementary, and then we learn more engineering, the physicists, and the engineers also learn more quantum mechanics and quantum information in the process. I mean, there are already courses going on in the engineering department on quantum communications, and then this serves to complement the work that they're doing in the network. So I think this is really a very nice development. And there is a lot of interest from the students. But there is this problem with the scholarships, and this affects much more the people in engineering and computer science. So nowadays we are focusing more on scholarship for undergrad and master students, so we could at least form the people when they're close to the university. But it's really hard to keep the engineers and computer science involved in the field. And we are trying to do exactly, as she said, I mean, we try to complement. There are some scholarships that you can complement other scholarships, or sometimes you can only hire an engineer as a part-time engineer, but at least they get involved as well in the process. So, I mean, there are roadblocks, but I think overall, I see a lot of progress. I think at least there is a lot more of interest, I would say, for people get involved. And I think the students, you see that they want, the undergraduate students, you see that they want to do master's degree. They want to keep on the field. I think that's good.
Any other questions? Rodrigo?
Hey, I'd like maybe to ask like your expectations for the future. Like, where do you think that Brazil could be in like 5 years? I don't know, in comparison to what we have abroad already. Can we expect that Brazil would be playing as a front runner in the quantum communication field, or do you think that's being already like a second group of runner-ups would be already again? And also maybe a connected question to that, because I usually think as Brazil, in Brazil as like a regional hub, right, for science at least, right, at least in South America. So do we have also another initiatives in the directions of what you guys are doing in other countries in South America? Do you think that Brazil could be a bit of like a regional resource in this field? So I don't know, would like to hear a bit about this.
Well, regarding what I expect this all, what I expect it to become in the future, I don't know. That's the honest answer I can give you is I don't know. I think it will depend a lot on, because it does not depend only on our will to do it. Because as Daniel said, we are doing like national projects and applying for funding and etc. But there are also other constraints, other boundary conditions that go beyond our control. So what I think that this is a bigger question, a bigger issue in the sense that what does the society expect from us in this regard? So outside the academia, the driving force that I can see is more the military. They are desperate because they are afraid that they won't be able to communicate securely anymore if they don't develop, if we don't develop our own technology for quantum communication. So I think that this is the, outside the academia, I would say this, it seems to be the strongest driving field. There are a few startups or companies that are also interested in like, how can I say, investing money in this, but it's still very in the very beginning. So I think it's very hard to answer that. But I think that, you see, it's like in our, by the way, today was the first time I board the airplane in the priority, in the priority group, okay? This was the first time in my life. So I have already experienced quite a bit of our science history, and I can tell you, we never took for granted what would happen in the future. We never knew what was going to happen. We always worked with passion and with will to do something. So I think that the best we can do is just keep doing, like keep thinking that positively in the sense that let's work as everything will do just right. I'm sure, I don't know if we are going to get exactly what we are now looking at, but I think that we are going to get something much better than if we think otherwise. So I would say that just let's go to work. That's it.
You asked if you think we're going to be the second runner-up or the third, and I don't think we're not even going to get the fifth, okay, in a few years, not in 5 years. And one thing that I think we keep forgetting, right, and is that, and that's because the community here is mostly scientists, so you have to do it different, not necessarily better. You have to do it differently because that's the way you can publish, right? So, and one thing, but when we look at the Asian countries, you look at Japan, you look at Korea, and you look at China. All of them have the same trajectory. They started copying, then they mastered it, and then they innovated. We have always to start innovating, and we don't copy enough. That's my sense. So I think we needed to put the pride a little bit on the side, and so that we can also copy, because we learn a lot through copying, right? We understand, and especially when you're talking about something that you're going to manufacture one day, you understand the cost structure, you understand what the market wants, because if you just innovate because you do it differently, you're not necessarily doing what the market needs. You're not going to have a competitive advantage. So indeed, and you don't just dream that up, right? You have to experience it. So I think copying is underrated. I think we should do more copying because that's the way for us to grow, right? And to do that. Having said that, I'm not sure what's going to happen in 5 years, but I know what can be possible. I think it's possible, and that's what we should fight for, right? I want to have a company that's selling a a national QKD system, because I think that is essential for us to be able to have national soberania nacional. Yeah, sorry. You're not going to have that if you have to keep importing all the kind of systems, right? And there is interest enough from the defense and from the banking industry that I think it's possible to have not a huge startup, right? But a company that will be able to be selling that. And that can open the door for other types of products, because our communication industry basically died, right? Because we start developing something, and then comes an economic crisis, and people to survive start representing other companies, and then they find out they make more money doing that than developing their own products, and then they stop developing products, and then another crisis, everything dies, and then you start all over again, right? But I think that this might be different. Why? Because there is interest from defense, and defense can be the one that finance and gives the sustainability for a company to start. That's how Embraer started and survived, right? They had a defense, the aeronautica financing them for many, many years, so that allowed them to survive all the crises. So I think this type of technology is a good candidate for that. So if that's going to happen in 5 years, I don't know. Is it possible? Yes, and that's what we're going to try to get.
So I'm going more or less in line with Valeria. I think this movement that we're seeing in quantum technology nowadays, I think it is driven not only by scientific questions. I think it's other portions of society want this to happen. And there is the need for other portions of society. I think mainly for military, but also from other private sectors. I think they feel the need to develop a national technology. And I think this is a different drive than what we are used to in the academia. In the academia, I think it fluctuates a lot more. That's what Rafael mentioned, is that the small amount of funding, and it goes away and then goes up a little bit. But the funding that's direct more to do technological development, and that's what we are discussing here in quantum technology is something related with technological development, I think this is a different kind of money, and that we need to learn how to work with that. I think the academia. I think we have a lot of knowledge, I think, in quantum information, but this knowledge was always, I mean, developed in a situation where the funding was really scarce. There's almost no funding. So I think many people got used to do justice, a small experiment, a small analysis, and don't do like something that's more, I mean, consequential. Some of the experiments are more consequential, but are more hard to do as well. But with this new flux of money, then we are able to do larger projects, and with a mix, with some applications that we can really have some innovation results, but also do more interesting science as well. I think it's possible to combine the two things. In my view, I think this is something that always work well. I think in the US and Europe, try to combine the scientific motivation with the technological challenges. Because, I mean, the scientific motivation is also important to really motivate many people, I mean, many talent that want to work on a particular project. So I think if we are able to combine, then we can really bring talent to contribute to that challenge. But we certainly need to do more innovation, because I think this movement that we're seeing, that's not purely scientific for sure. I mean, we really need to deliver solutions, technological developments together with that.
Well, I think just on the matter of where we are going to be in 5 years, I think it depends a lot on how we deal with our demand on consumables for quantum technologies, in the sense that, like, we are trying to make sources and detectors and, I don't know, full-on QKD apparatuses that we want to maybe produce. But if to do that we need to import photodiodes from Germany, we might face issues. Like, I don't know, today was the very first day where I received an email saying, hey, yeah, I'm not going to give you a quotation. Yeah, I'm not able to supply your demand. Something like this for coatings, for mirrors, which we also don't do here. So I see an increasing problem, and people have been mentioning more and more that because of how sensitive the quantum technological scenario is, some countries might impose some boundaries. So if we don't make our own things, like at least some key elements, then we might see that even with the funding, we cannot do much in the future. So I think if we have the funding, but not the means to buy what we need. If I cannot buy a nonlinear crystal, what can I do? Yeah, but so I think one thing that we should do to protect, because what we see is now there is an increasing feeling about quantum computers, for example. So if there is let's assume that in the future quantum computers do become a more commercial thing, then I think the demand for quantum comms will increase, and then it's going to be very good. We're going to have more money and more responsibility as well, but we won't be able to advance much if we don't have the basics, like nonlinear crystals, like photodiodes, or coatings for mirrors, and the basics, these kind of things. Yeah.
From my point of view, I think very important is the sensibilization about how important is the quantum technology, because it's not something only related to the academic environment. I think a good example is 5G. It became a standard. It was introduced in Brazil, but I don't know if it really changed business opportunity. If Brazil is investing in terms of using with more effort 5G technology. The same thing is for the quantum technology. What happens in Bahia is really interesting because we prepare people in quantum engineering in order to integrate quantum technology in our life. So this is the starting point. I don't know in 5 years, but if it happens something like the 5G, so Brazil adopted just because it's a worldwide standard, I think this is not enough for being in the first position in this environment where quantum technology is playing a very important role at the moment in the rest of the world.
Yeah, so just to compliment, I don't know where we are going to be in 5 years. Where I would like to be in 5 years, like that we are in 5 years, is that we change, like nowadays I feel that the academia is like a Ponzi scheme, like a pyramid scheme. I have students, these students will become professors and form new students that will become professors again. So, I mean, that's not the point. Like when I was in Europe for 7 years, like in Spain and Germany, and in both groups I have the impression that like 20% of the PhD students and postdocs, they went to the industry afterwards, and only 20% stayed in academia. And here, like outside academia, we basically are jobless, right? So I really would hope that this changes, and I feel it's changing a little bit. Like I would never imagine that, but like in the last years, I've been talking to people from banks and from, I don't know, startups and big data companies and so on and so forth. So like people are starting to get jobs in these new markets. And I think this is the key. If we are going to manage to do that, I don't know, but it's where I would like us to be. More intersection with the productive sector.
Yes. First, thank for the talks. Imagine that we had like the infrastructure to do those like key elements to make the research that we want. So the oscillators, the photodiodes, and all these things. Apart from the people in the university and doing research, like who would buy? Because even if you had like this infrastructure, it costs money. And I don't think that we as university and research group would have enough capability to fund eternally this infrastructure. So this is a problem of sustainability, as Valéria said. How would you make this ambient sustainable to make this possible infrastructure continue?
You touched a really important point, and that's one that we struggle every day, because when we talk to, every week we talk to 2 or 3 companies, right? And we are trying, and the thing is that we have a language that when we talk to them, at least our researchers that I'm training not to be like that, is they start explaining why and how, and they don't want to hear why and how. They want to know what for, right? And so the question is, I don't see quantum communications or QKD, which is the closest one to be on the market, right? For you to use in applications that are widespread. They are going to be niche applications at first, right? And these niche applications, which are those applications? Are the ones where you need to have secret or need to be protected for a long number of years. So you have sensitive information that need to be protected for a long time, or that it's a communication that you have to do that is an infrastructure. So you need to look, you need to understand the voice of your customer. So who is your customer, and what is important for the customer, and how you pitch your talk to them. So we had a session, a brainstorming session last week, trying to figure out what would be for the government agencies. Which are the government agencies and how we can get support from them. How can we make a demonstration that we can do. The other things that we see from the customers is that they talk about it. So can I see it? It's already done, or it's something that's going to be only in 5 years? How you can get, so they have that urgency. And that's why we are trying to, we started looking at how to integrate the systems with the classical, because doing generating the quantum state and detecting it is only like 10% of what you need, right? You still then have to do the reconciliation. Then once you generate the key, you have to talk to the key management system. Once your key management system is in place, then you have to talk the applications to the encryptors, right? And how you're going to encrypt it, and which applications are important, and which protocols you have, because you have a ton of those encryptors for different applications. But even when you talk to your customers, they don't want to hear that. What they want to hear is, what is the case that we have? So one easy place for you to explain, you talk to the Justice Department. There are certain systems, right, certain lawsuits or documentation that need to be secret. You need to be kept. And how do you guarantee that? Because it's very easy for a criminal to attack the system and get that information, right? And this needs to be stored for a long period of years, right? So this is a good candidate for that kind of application, right? What other kind of applications? We have, if you talk to the to other industries, they are going to be different. I think one candidate might be hospitals. We are talking to 2 hospitals. Why? Because hospitals are targets for ransomware. And when they are attacked, they lose control of their equipment, their surgery room, and all that. So that we may be able to convince them. The truth is that when you talk again with the cybersecurity people, they're going to tell you that the easiest way for you to get a secret information is ask the person for the password, and they will most likely give you that password, right? It's not breaking a key. That's very technological advance. So so you're not gonna, those applications, the form to protect that, it's completely different. But there are, for instance, synchronization of data centers, which carry sensitive information. That might be application. So we need to understand that space, the usage space, so you can start working on those. And that is with basically any new product that you introduce. Usually you find a niche application that is not so sensitive to costs, so you can try and recover your cost and can afford it, because when you introduce the product, it's somewhat more expensive, right? So it might not be cheaper. And you use those niche applications to gain knowledge and to lower your cost. Right, your production, you learn how to produce that better, how to lower the cost. And then you're going to start opening side applications and then propagating that. So finding those applications, I think, is the key. And that's one of the efforts that we are doing, because otherwise we're not going to get out there. We produce something that somebody's going to sell, and then it's not going to have a customer. We have to find those that feel compelled and have an application that's really interested that has that need. Because the biggest competitor for QKD, or quantum communication information, is post-quantum cryptography, right? So, and post-quantum cryptography can go a long way for many of the applications, and it can be done remotely, right? Or wireless, let's say, which you can't do today with the QKD. Or you can have it, but you need line of sight, and then you have so many limitations. So understanding that, and also integrating that with the existing system, so you can actually get the advantages, understand where is the differential advantages and what applications they are needed. That's, I think, that one of the most important things.
So I think that, I mean, this is certainly, I think, a challenge in how to really grow applications and how to support the development, I think, in Brazil. And I think we have peculiarities that we don't see as much abroad. I mean, I think in Europe at least and US, they have more of a culture of developing the product and really funding startups that develop something very new and that will basically start a new demand, and because they introduce something that's more disruptive. And I think this is challenging here in Brazil. We have to have some kind of strategy really to really grow, and we cannot rely as much in funding really from the startup, from the beginning. You know? But I think it's possible if you can really grow some simpler applications, even if you look for the more disruptive products in the future, because this in essence is what is inside quantum technology. I mean, for example, for quantum communication, I mean, quantum key distribution is interesting and it has a very clear application, even though still there are some debates about what's the role of quantum key distribution, if it's necessary for the amount of work that it takes. I mean, we have different approach from the United States and from Europe and China. The United States is really betting in post-quantum, and Europe and China are betting in post-quantum plus quantum key distribution. And so it's not really completely clear what's the future. In some way, it depends on how the quantum computers are going to evolve. And that's another issue. And so the quantum technology has this doubt about what's the future. But I think this is the nature of the problem. But for example, for quantum communication, I think people in the field feel that there are many more applications if we create networks of entanglement. And that's also the bet of the United States. I mean, all the quantum networks in the United States typically are quantum networks of entanglement. And so you can do distributed quantum computing, you can do quantum sensing. But again, these are more applications for more in the future. I think building most of the large quantum networks in the world are quantum key distribution. Even though probably in the midterm or long term, probably we're going to have much more applications for quantum entanglement networks. And so, I mean, it's a hard balance because we need to do the new develops to maybe develop products, but I think we need also to keep an eye for what's going to be important for more further away in the future. No?
Well, hello everyone. Thank you all for being here and sharing with us your thoughts and rich experience. Well, my question comes from the perspective of a student who is kind of beginning in the field. And I noticed that quantum computing is really popular and it's getting more and more popular between the people in general, but also in the tech sector. And the problem for me is that there is a gap between the time scale in the academia and the tech industry. So my question is, if you're watching the growth of a bubble of expectations, and what happens when the bubble bursts in terms of, is it dangerous for the community and for the field?
Well, I've been hearing that the bubble will burst for I don't know how many years now, and my impression is that this is not going to happen. I mean, I sincerely think it's happening much faster than everyone expected. We have really, like, every year a new breakthrough result on error correction, on like a higher number of qubits and better quality, new technologies. I mean, it's your future, but if I would be young, I would just go for it, like quantum computing. I would have no doubt about it.
I would like to make a comment about what happened in the past. We are talking a lot about development in the future, but look, we have already passed through this kind of process that we are passing through right now. In the beginning of the 70s, during the time that was called the Brazilian Miracle, and at that time, we had our own car industry. So there was a totally Brazilian car called Gurgel, and actually this industry did not survive the competition against the foreign manufacturers, especially when they established their plants here in Brazil. Also, we had our own computer brand that was called Cobra, okay? And people used to make jokes about the computer. Oh, it has problems. How can I say? It like blocks all the time and so on. So instead of like trying to improve the product, improve our technology, it was like bombed all over. So, but at some point, we had our own Brazilian computer. It didn't go, and actually, it depends a lot on what big people in the people that take the big economical decisions, what they decide in this respect. Sometimes they just take the easier path. That is, okay, let's give it up and buy whatever. Let's plant more soy and sell more soy, more meat, and buy all this stuff, okay? But even, it's not only a problem of crisis. You see, when all the telecom system was turned to private owners, because it used to be, when I was a teenager, all the telecommunication system was from the government, was not private. When they privatized everything, all the telecom system was bought by foreign investors. And one of the conditions, it was on the table, on the negotiation table, is to stop all research in telecom system, in national telecom system. The CPQD in Campinas suffered a lot of that. They just destroyed a whole research institute devoted to developing Brazilian technology. And it was a decision made at and Embraer, it was not only a matter of crisis, economical crisis. Embraer was about to be sold to Boeing. And it was not sold because the American government blocked the operation. It was not blocked here. The Brazilians were ready to deliver Embraer to Boeing. So it is quite hard to tell what's going to happen in the future, but especially if we don't accept to pass through some period where our technology will not be so good, okay? And after, by the way, the same stuff that they used to say about the Brazilian cars or the Brazilian computer, they used also to say about Japanese cars in the beginning. Japanese cars were considered completely crap. Can you imagine this? Japanese cars, when they started, they were the worst cars. And they were cheaper. So they started by being cheaper. Then the Japanese, they learned how to make quality control. So they knew that quality control, you need to test. So they started to make the following. How many times do they test an American car's door? They shut the door like 1,000. Then we are going to shut the door 10,000 times. We are going to test 10 times more than what they do. So that's how they improved the quality of their product. And that's how Japanese cars became what they are nowadays. But when they started, they were completely crap. And I saw that. I lived in the States in the beginning of the 90s, and I saw the old Japanese cars there. They were pitiful. They were like cartoon, like Flintstones cartoon car, And nowadays, they are the top cars in the world. And they practically broke all the American manufacturers. So you see, this is something that we have to go through. And we should not make sabotage against ourselves. We must convince politicians, the society, that we need our own technology. And what Valeria said, I totally agree, 100%. We must start by copying, and I really believe in the Brazilian creativity. We are very creative. Otherwise, we could not have survived scientifically until this point. And I really believe that we will be able to add many, many valuable knowledge to whatever we learn to do.
You mentioned the Japanese in the car, and the Toyota, the main innovation was the total quality, right? So when they innovated that, they basically, any technician, didn't matter how low they were authorized to stop production to fix a problem when that problem was encountered. And so they had this whole thing. So there is a bunch of different cases to study that. And it became so fashionable. I was working at Corning at the time that Corning adopted total quality. And then they started bringing that to the whole company to do that. In my first year at Corning, I got an apple that they called Quapple, because it was the quality apple because of something I had done at the time. So that was considered a prize for whoever did some job well done. And it's amazing, but it's true. They started. So if I look at in those days too, we had an optical fiber company, right, which was bought because in the bubble of the telecom bubble, everybody wanted more, so it was bought by Pirelli at the time. I don't know who was it. Pirelli. And then the bubble burst, and then Pirelli sold it. So the same would have happened to Embraer if we had sold, right? Because then came the crisis, Boeing is in a difficult financial situation, they would had closed it. So these are important lessons that I think we should learn not to repeat, right? Because once we develop something good, we look at the BR Photonics, and before that, and our idea, they build it, they are successful, they sell it, and then in the first crisis, then the company destroys it. And then the same person goes and opens another company and hire everybody back and creates another company, and then they sell it again. And they do in this cycle, I think they're on the third or fourth time doing that. So in a way, they are very good. Julio got a lot of money, so now he's financially independent, and he has his own company and is applying for that. And he's being able to get, the latest thing was when they sold the company to Lumentum, and Lumentum bought them because they want all their electronic folks, the FPGA folks, right? And that was, they want the people, they didn't want the other things. Then there was a change of Lumentum leadership, and they decided that that was not important anymore, was another part of the business, so they fired everybody. And then they are using now the people that do integrated optics. So it's a global world, we have to be mindful of that, but I think that quantum technology has the chance because I think of a need for, a government need for having a company that is Brazilian. And that can allow us for surviving these early waves and give some sustainability.
I'm totally agree, but I think also it's important in order to survive in the quantum world to recognize the importance of the intellectual properties, because academic community is used to publish very fast and without thinking about to protect the idea. This is the engine for after building a startup to preserve the know-how inside the country. And this is the reason why a small startup in the Greece, normally bought by a big enterprise, is not interested in the production line, but in the intellectual properties. Sure, for sure. Exactly. But intellectual property, I think, play an important role in this moment. And as you say, Valeria, also reverse engineering, no, not copy. I was working in a.
It's an item for copy.
No, it's quite in big company quite common to have a group working the reverse engineering in order to learn, and with a small change, put on the market a new patent and a new product with small, little change. But at the same time, the same product, just maybe more cheaper and competitive with the other supplier.
Maybe just a brief comment, because you asked about maybe the perspective as a student, someone like starting in the field. I think it's a very nice moment for that. And like just let's assume that it's a big bubble and that it's going to blow up like in 5 years or so. You will have learned so much, and there's a lot of momentum in the field now, so you have the chance to interact with many groups that are being well funded and are using like top-notch equipment and having like visitors from all over the world. So I think the skills that you're going to acquire, they are not going to blow up anyway. It's not a speculation bubble. So I think it's a good moment for a student to start in the field. I think so.
Okay, thanks. This was an amazing discussion that we were having right now. And I just want to go back a bit to, about the sustainability thing, because it started with the question about, you know, if we have the diodes and things, who's going to buy it? And it made me think, you are now facing a series of sometimes even classical challenges that you need to solve and, you know, come up with solutions going up to this big product or, you know, this big quantum application. But do you see that on the road to that big quantum application, can you already see maybe some components that could be made maybe almost as efficient but cheaper than something that your competitors in Europe and in the US use, let's say so, a dedicated FPGA card to do key reconciliation that would be cheaper than what's being used by Toshiba, I don't know, or something that, you know, that could already become this, maybe not the Gurgel car, but the cheap and not so bad gearbox that in the end everyone uses to do at least tests or something.
Não vou falar. I think we have some different takes among us or the different projects that use slightly different technologies, and for those you might need different products that might be beneficial now. The restriction that we'll have, and I think it's going to increase on certain technologies, I think instead of limiting us, they are going to force us to be more creative. So it might actually be a blessing in disguise, depending on how you go about. In terms of technologies that I see that we don't have basically photonics, we don't have anything, right? Because the whole photonic industry got destroyed, right? We have very few things that we do. But there is one group at UFAL that I think they have some nice technology that we can make it in Brazil because it doesn't require so much of a costly infrastructure, and that we are going to be developing. But I'm not at liberty of saying exactly what they are doing. I think that's, that is one. We are constantly looking at that, and I think what we can do is not use necessarily the state of the art, but adapt something with components that are more easily accessible, right? And that will be the Gurgel case, because they are not going to be as good, they are not going to look nice, but it might be sufficient for some applications. That is one of the reasons that we end up choosing the CV QKD. It's because you basically can buy off the shelf all the components you need. So you won't be limited by the technology that we don't have, right? But there is applications. The area of FPGAs and chips, electronic chips in general, Brazil is all the way behind. So I don't see us becoming independent in that area anytime soon, because it's a global industry. Everything is done, the chips are all done in Asia, and they are assembled somewhere else. I was reading something about that chain of supply, the supply chain, and it's like there is the chip that is done in Taiwan, then it goes to another place where they package, then another place where they integrate, and another place where they do the packaging for shipping. So, and all these other places are different countries. So I don't see, for instance, for FPGAs or electronics, us becoming independent. What we can become independent is in the programming, the know-how, in the use. And that's also the path that the Asians took, right? They started integrating things, right? Then they start going down and looking into manufacturing the key technologies. But the great thing about the Asians, which we are not, is their patience. Once they decide on doing something, they make plans for 30 years, 40 years, and then they follow those plans. We can't get a plan over 5 years, right? That's a problem.
Yeah, so I think, in my view, I think we have plenty of room to compete, in the sense that we are going to do largely copies, but with modifications, of course. but I think we do have rooms. I mean, actually, the quantum technology is quite expensive. That's in the market, and so this gives us some start. I mean, to gain in building it differently, and I think we can still rely somehow in importing some portions of these equipments, but we need to rely in parts that are not coming from single countries, I would say. I feel more comfortable when some technologies can be sold by Europe, China, US, and if you have a broader base that you can buy, I think this gives more robustness for the solution. But I do think that there is space to grow. I mean, doing smaller equipments, but because it is actually not simple and not cheap to buy things ready. I think many companies in Brazil nowadays are starting to make plans to buy, for example, QKD systems, and they're not cheap at all. So there's some room.
Pierre, I know that you bought 1,000 electronic photo counting. I know because I ordered it for you. So what do you think about this? Have you used it?
Yeah, so actually I was, maybe I need a mic right in the shower. Thanks. So yeah, so experimental problems apart, I actually, after I bought that one from Switzerland, I learned that there was a Colombian company that was making something that is much cheaper, maybe not as good. And I thought, maybe I should have bought the Colombian one. So that's exactly
Colombia.
the direction I
Colombia.
was thinking. Yeah, exactly. That we,
from Colombia.
when I said FPGA, I don't really mean that we make the FPGA chips, because no one is making that except 2 or 3 companies. But to make FPGA-based modules for time tagging, time correlation, stuff like that. Exactly. That's you read my mind. It's
Yeah.
exactly what I was
So
thinking.
you see, why can't we do that, you know?
Yeah.
So in Colombia, they are doing this electronics. It works. By the way, when I bought one, we used one of the ID Contic, and we used the one from the Colombian one from 1000, which is much cheaper. And you know what? My students, they prefer to use the
Exactly.
Colombia one.
Yeah.
Is much easier. It's much easier to implement, to use everything. And it's like, it's nothing. It's a neighbor doing this, you know? Huh?
Yeah, see?
Thousand. T-A-U. They
Yeah. No, you absolutely read my mind. It's exactly what I was thinking.
Okay.
That they, yeah, exactly. It's that kind of thing that we could develop, and yeah, perfect.
So I worry a lot because I see that you are working with devices, developing. Felipe Barbosa, you are doing the same. Tiago is doing the same. Huh?
We had the board from some companies.
Oh yeah. So
What do they sell at this 1,000? This 1,000 company, what do they sell?
the time taggers, time taggers. So. No, it's not. No, it doesn't have anything to do with Alejandra. No, not at all. They are engineers. No. Maybe at some point. I don't know. I'll ask her. Really? Oh, okay, maybe.
Just a brief comment, because that kind of answers to a previous question as well. I think science itself is a market also. So I think there is space to make scientific equipment that we could at least sell within Brazil and within South America, which is already a quite interesting market. And if we make it attractive, then why not to Europe, especially now, with this whole tariff situation going on. We don't know how much this is going to drag along. But just to give clear examples, I think there might be a sweet spot where you can develop something that is interesting for you, research-wise, that you want to publish papers on it, and that still this might serve other research groups that will bring collaborations and maybe turn into a product. So there's 2 examples. One, in Canada, they developed this thing that they call a Q-plate. So if you want to generate these vortex beams that Zella showed, that was very difficult to do. And in Canada, they developed this liquid crystal thing that you apply voltage, and then you can generate this a non-uniform polarization pattern. And after that, there's people from all over the world that are using them and creating new collaborations. And I don't know if you can buy them, but that's one example where fabricating something that is niche becomes spread worldwide in a very interesting way. Not to bring money yet, but that's one example. And the other is exactly regarding lithium niobate. I know that is something that Felipe Barbosa is working on in Campinas. And currently, there's 2 groups that I know that are doing actual research on periodically poled crystals. One, it's Adi Aryeh in Israel, because he's closely attached to Rekel, which has basically the monopole on PPKTP. And the other one is Christine Silberhorn in Germany, which is doing the same for lithium niobate. So these 2 research groups, they are publishing a lot of nice work, really a lot of nice work, but attached to that, they have companies they are selling crystals. So if you want to buy a crystal for your experiment here, for SPDC, if you have even this slight difference between what they already sell, you have to pay really a lot of money, 10,000 euros for a single crystal, if you need something slightly different. And I think that kills a little bit the research on the topic in Brazil, that we don't have this kind of situation. So maybe one like midterm goal that would definitely benefit the scientific industry in Brazil would be to have this like facilities to produce those crystals and to make the periodic polling, for example. But there, of course, there's many others here.
I'm afraid that we're running out of time by now, so maybe I just have seen a less hand raised from the audience, and let's make that the last question of this session. So.
Thank you, everyone. It's just a complimentary commentary. So I think everyone knows about what happened with SAIFR. So it's in the line that you were saying about have just a single crystal or something like small that we can research with more. With less difficulty. How can we, I don't know, make some pressure in the government to not cut the fundings about these enterprises that are from the government, but they just cut the funding, like say TEC? I just don't understand that. It's so complicated to me. I definitely don't understand because the ships, they were coming out, but they cut more than half of the funding, and the SAIFR almost shut the door. So I don't know how to like get out of this situation, you know.
Any comments on SAIFR?
In general, I think that is, I mean, I am in no position to pressure the government yet. I think that is something more on the politics side. Yeah, I mean, science-wise, I think it's something that lies on another sphere. But, well, I think there should be space for us to build, like, not something that is a product yet, but something that we know that we are going to need in the future. Like, I don't know, something that can be interesting for research. That, of course, I'm referring to this thing with nonlinear crystals because I like frequency conversion for different things. And that's something that I know that at some point I won't have the money to buy. Especially if I have to talk like for 3 days with a company to ask specifically for what I need in that polling period or something, it's not gonna happen. But like this kind of a niche thing, it's a niche, it's going to serve only for my research at this point, but well, I mean, that's the kind of thing that develops into a product like slowly. So I think this is still at an early stage where it's like not so sensitive to government decisions as much, only on the amount of funding. Yeah.
Isn't there any group that grows lithium niobate? I remember it being done in the 80s.
Not that I know of, not here. So we like, I have to buy it either from Taiwan or UK.
Another skill that we lost, or capability that we lost.
Okay. So, okay, we're quite along on time, but it was a good session. I think it was a good and productive day. So I'd like to thank all the speakers in the audience. Barbara?
I would just like to thank everyone that came and our invited speakers, especially the ones that went overnight to be here today. And thank you very much for this nice day.
And let's And especially thank ICTP-SAIFR for this opportunity and for inviting us, for assembling and bringing all those people together. Nathan, Dario, and Gustavo for the initiative for this third stage of this series of meetings. So, Gustavo.
I just want to advertise for the next one, right? I got to make sure we get all this audience in the next edition. So you can always come to the website because this is being done live as we run it. We usually don't have the next date but usually we've been doing this every 2 months-ish. So we plan to have the next meeting on, it's called Critical Infrastructure for Building Quantum Devices. So a lot of the questions that were put forth here will be discussed in this next session. And this includes not only testing, Valéria mentioned test beds, Rafael is wondering whether someone can grow lithium niobate in Brazil. Zella is concerned about polishing mirrors, as I learned from the meeting, right? And these are all things that we should be discussing in this next edition. And I gotta say, for myself, I've been learning a lot from this series of meetings. And I hope you guys are learning too. And of course, you are welcome to come again. And this has been all not streamed, I think. Dario can correct me, right? Is this being streamed live? But it goes to YouTube at some point. So if some point you know a person that might be interested in catching up and part of the discussion, you can always forward a YouTube link so that we reach out to a broader audience. So thank you all again, and especially Barbara and Marcelo for putting up this excellent lineup of speakers and discussions. Thank you very much.